Alright, let's look at lesson 84 in Saxon 54 math. We are going to be talking about decimal numbers to thousandths. Notice the TH at the end. So thousandths means it is going to be to the right of the decimal point. Okay, so just a quick review on decimal places. If this is your decimal point, you have different places that go on the right and left of that decimal point. So this would be your units, tens, hundreds, thousands. On the other side you have tenths with a TH, hundredths, thousandths, 10,000ths. Okay? So just keep that in mind as you work through this. If you haven't already, go ahead and do the warm-up right here. Don't negate your division facts, that's very important. And you can begin to do the mental math here with patterns using counting by fives, review your multiplication, subtraction, and then right here there's one that says estimate the percent of the circle that is darkly shaded. So notice that right down the middle, that would be 50%. It's not quite 50%. If you had a quarter, that would be 25%. Half of it would be 50%. So you're somewhere in between 25 and 50. So if you said 35, or maybe right in the middle there between 25 and 50, if you said that percent, that would be fine as well. Okay? Alright, so go ahead and do those warm-ups and then come back and we'll continue with the lesson. Today's concept, we are looking at, again, decimal places to the thousandths. So it says here in investigation 4, you practice writing fractions with a denominator of 10 as decimal numbers with one decimal place. So for example right here, 7 over 10 is, 7 divided by 10 is 0.7, 7/10ths. That's what that means. So you can read this as 7/10ths, and you can read the decimal as 7/10ths as well. Often we say 0.7, but it's also 7/10ths. Okay? In addition, you wrote it with a denominator of 100. So if you have a number over 100, then you're going to move the decimal point over 2 places. And that's going to be 0.12. This is read as 12 hundredths. And this is read also as 12 hundredths, either one. Now we're going to be writing decimals and fractions with the denominator being 1,000. So that means you're going to be working with thousandths. So 125 over 1,000, if you take 125 and you divide that by 1,000, when you divide by powers of 10, you move the decimal point to the left. So that means the 125, if it's not written, the decimal point is understood to be at the end. So if you move that over 1, 2, 3 places, 1, 2, 3 places, you're going to have 0.125, and that is read as 125 thousandths. Okay? Same with the fraction, 125 thousandths, when the thousand is in the denominator. In addition, if there's only a three-digit number up here, you still move it over 3 places. You just are going to have to insert a 0 there as a placeholder. So 25 divided by 1,000 means you're going to move this over 1, 2, 3 places. Well, that means you're going to have to put something in there in that placeholder, and that's going to be a 0. So 0.025 is the same thing as 25 thousandths. So write 375 over 1,000 as the decimal number. All you need to do is take 375. The decimal point is understood to be at the end. Move it over 1, 2, 3 places, and you've got your 0.375, and that is 375 thousandths. Either way you write it, either as a fraction or a decimal, it's 375 thousandths. Write each decimal number as a fraction or mixed number. So in this case, we are going to write these. You'll notice that this is out to the nearest thousandths. Okay, it's 1, 2, 3 decimal places to the right of the decimal point. So that is 625 over 1,000, or 625 thousandths. Okay. Now you always want to try to reduce this. So as you reduce the fraction, you're going to see that 5 goes into 625. So if you take 625 divided by 5, you're going to get 1. Bring down the 2. 5 goes to 12 2 times. That's a 10. Subtract. Bring down the 5. That's going to be 5. So 125. So if I take 125 and divide by 5, 625 is the same thing as 5 times 125. Well, 1,000 is the same as 5 times 200. So the 5's can cancel. And now I've got 125 over 200. And I'm going to try to reduce again, because 125, you can take a 5 out of there. You can take 125 divided by 5. 125 is 5 times 25. And 200 is 5 times 40. So I can take another 5 out of there. And 25 over 40 can continue to reduce as well. So 25 is 5 times 5, and 40 is 5 times 8. Another 5 can be canceled. And you end up getting 5/8 is your final fraction here for this. Now, originally it was 625 over 1,000. That is what they're looking for. But I also want you to practice reducing all these fractions to get the simplest form. Okay? All right. 3.125, notice it is out to the third decimal place. So 3.125 means 3,125 over 1,000. Well, that actually is, your number up here is bigger than 1,000. So you've got 3, and then you've got 125 thousandths. You can also write it like this as a mixed number. Okay? So 3 and 125 thousandths, or 3,125 thousandths is the same thing. But this 3 right here takes care of the 3,000 over 1,000. So if you just have 3 and 125 thousandths, and then if you reduce this 125 thousandths, you'll notice that 25 goes into 125. You have 3. The 125 here is 25, another 125, another 25, another 25, and another 25. 5 25s. And 1,000 is going to be 40 25s. Okay? So 25s can cancel, and you have 5 over 40, which again, that even reduces. You're going to have 5 goes into 5 one time, 5 goes into 40 8 times. So this actually all reduces down to 3 and 1/8. Maybe you haven't worked with reducing fractions very much, but that's just a little preview if you haven't. Okay? So you can write 3 and 125 over 1,000, or if you reduce it, you got 3 and 1/8. Okay? All right. Since there are 3 places, okay, they've talked about here the solution, so you can look through your solution here if you want to, and just see. Notice they didn't reduce it. Okay? So you can ignore my reducing for right now. That's just a little bonus footage there for you. Okay? So just practice with writing it at over 1,000. Okay. Let's look at writing these each as a fraction or a mixed number. So this is your lesson, and if you haven't worked on this already, you can pause the video right now and practice these first before you come back to the video and look at my hints. Write each fraction or mixed number as a decimal number. So this would be 0.425. This would be 3.875. This would be 0.035. And this would be 2.007. So hopefully you see the pattern there, and you can do that as quickly as I did. If not, go back and review a little bit what we did in this new concept lesson. Okay? Write each decimal number as a fraction or mixed number, then use words or names to number. So this is going to be 214 over 1,000. This is going to be 4 and 321 thousandths. This is 25 thousandths. This is 5 and 12 thousandths. This is going to be 3 thousandths. And this is going to be 9 and 999 thousandths. Notice all of these are taken out to the nearest thousand. 3 decimal places to the right of your decimal point. Okay? Alright, let's look at the problem set. Pause here, go through it yourself, struggle, 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 fight, 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 and make sure you understand everything. Come back to the video, and maybe what I share with you will help you. Okay? Alright, if it is not a leap year just means that February has 29 days instead of 28. Okay? What is the total number of days in January, February, March? So, not a leap year. February is going to have your 28, is that right? March is going to have your 31. If I did that right, okay? Total number of days in January, February, March. So if I have those numbers right, you can check me, okay? You're just going to add up all the days in each of those months, okay? Alright, the shoemaker's wife made each of the 12 children a pair of pants and 2 shirts. So 1 pair of pants and 2 shirts. How many pieces of clothing did she make? So she's making 1 pair of pants and 2 shirts. That's a total of 3 items, and she did that for each of the 12. So you're going to take that 3 times 12 to get your total number of clothing items that she made. John did 7 more chin-ups, 7 more than Paloma did. So John did 18 chin-ups. How many chin-ups did Paloma did? So let me just write something here for you. John, I'm going to put a J for John, did 7 more chin-ups than Paloma. So here's Paloma, J for John, P for Paloma, okay? Who did more? John did more. John did 7 more. So if I wanted to equate these, Paloma would have to do 7 more chin-ups in order to match John. So Paloma's number, if I take Paloma's number and I add 7 to it, then I would equal John. So notice this little equation here showing me John's number of chin-ups would equal Paloma's if Paloma added 7 more to hers. Okay? John did 7 more than Paloma. That's what that means. John did 18. So John did 18. So how many chin-ups did Paloma do? Well, Paloma did 7 less than John. Or Paloma has to add 7 to match John. Or in other words, 18 minus 7 is going to give you Paloma's. Or Paloma plus what? Or plus 7. Sorry, let's write it this way. What plus 7 would equal 18? So however you answer that, however you question that, you're going to end up getting that Paloma did 11. Okay? Khadija drove 200 miles at 8 gallons on 8 gallons of gas. Her car averaged how many miles on each gallon of gas? What that means is she did 200 miles and the car consumed 8 gallons of gas. Well, that means that for each gallon of gas, on average, how far did each gallon take her? So you're going to take your 200 and divide by 8. 200 divided by 8. When you do that correctly, you're going to be finding the number of miles per gallon. Please pay attention to units. Units are very, very important. So you're finding, when you divide here, you are finding the number of miles per gallon for 1 gallon. Okay? Melinda paid the clerk $20 for a book that was priced at $8.95. The tax was $54. So $8.95 plus 54 cents is what she is going to pay the clerk. But she doesn't have that exact amount, so she gives the person a $20 bill. So now to find out the difference, you need to take this number, $8.95 plus 54, which by the way is going to be $9.49 if I did that correctly. Okay, I think so. But then she gives her a $20 bill, so you're going to take your 20 and subtract the $9.49. Okay? Alright, the tally for 8, this is how you mark the number 8. Like let's say you were counting the number of people that walked past you and you started to count them. Instead of writing the numbers 1, 2, 3, you can put just a mark. 1, 2, 3, 4. And then when you get to 5, you put a line across those 4. That's 5, 6, 7, 8. That's what they mean by the tally marks for 8. What is the tally for 9? You would just add one more right there. That's the tally for 9. 10 would be like that. 11, one more. 12, 13, 14, 15, etc. If each side of an octagon is 1 centimeter long, what is the octagon's perimeter in millimeters? So, octagon, you have to know that is 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, and each one of these, I didn't draw this very well, each of the sides is 1 centimeter. So that's a total of 8 centimeters, but it's asking for it in millimeters. Well, 10 millimeters is equal to 1 centimeter. So if you have 8 centimeters, you're going to have 80 millimeters. Okay? Alright. Number 8. 1/3. 1/3. 1/3 is written like this. 1/3 of the 18 marbles were cat's eyes. How many of the marbles were cat's eyes? Draw a picture to help you solve the problem. So 1/3 of the 18. What they mean is, often in mathematics, of means multiplication. So 1/3 of 18 means 1/3 times 18. Or 18 divided by 3, however you want to think of that. You're going to take basically 18 and divide it into equal thirds. Okay? Robert picked 46 peaches in one day. At that rate, how many peaches could he pick in 6 days? Well, it's going to be 6 times that. So 46 times 6, and you figure out what that is. Mary picked 3,640 peaches in 7 days. She picked an average of how many peaches each day. So this is the number over 7 days, so you have to divide that by 7 to find out how many per day. So you want to take 3,640 and divide by 7, or you can take 3,640 like this, 7 divided by, or 3,640 divided by 7. Okay? Alright. In a feat of strength, Jack did 1,000 push-ups. My goodness. 129 of them with one arm. That's incredible. What fraction of the 1,000 push-ups did Jack do with one arm? So what fraction? So you are going to write 129 one-arm push-ups over the total push-ups, which is 1,000. Okay? And then eventually we will be trying to reduce that and simplify that fraction. Write the answer to problem 11 as a decimal number. So as a decimal, you've got 129 over 1,000, so that's 0.129. That's going out to the third decimal place after, or to the right of the decimal point. Okay, write the answer to problem 11. Oh, we did that, sorry. And the name of that is going to be 129 thousandths. Alright, these here, I'm going to let you work on these. You should be able to do all of these computations. Very, very important. You should be able to do them without a calculator and work through them, struggle through them, and make sure you're doing all the operations in the correct order. Okay? Down here, number 27, meaning you can do all of these here, all these computations, you can do those. Okay? So you can do all the way down to 26, and then check your answers. 27, write 0.321 as a fraction. Notice it goes out to the thousandths place. So 321 over 1,000. 28, find the perimeter and area of the square. Perimeter, you are going to count the distance around. It's a square, so all the sides are the same. So just 3 plus 3 plus 3 plus 3, or you could even say 4 times 3, and you're going to get 12 yards for your perimeter. The area you're trying to figure out how many squares. In this case, each square is going to be a yard by yard. So you've got 3 across this way, you got 3 down this way. That's going to be a total of 3 by 3, or 9. Don't forget to write the correct units. It is yards squared. It's how many squares you are using to fill up that particular space. Okay? 29. Which transformations would move figure ABCD to position WXYZ? So it looks like if you took this particular shape, ABCD, and you want to move it to WXYZ. By the way, they're all named in the same order here. So A corresponds to W. B corresponds to X. C to Y, and D to Z. So you could just follow one of them if you want to, one of the pairings. If you see, what did A do to turn into W? So A was here, and now W is there. Okay? And if you see that, for example, B was here, and now the X is up there. So it looks kind of like you did a bit of a transformation where you rotated this 90 degrees. Okay? So you turned this object one quarter of a turn. So that would be 90-degree turn. Okay? That would be counterclockwise, by the way. Counterclockwise. Alright, and which angle in this figure looks like it measures about 45? Well, this is 90, that's 90. This is obtuse, meaning it's greater than 90. So your only option here is 45. And if you look, here's your right angle right there, that box. So it looks like it's about half of it. So that angle C, you could even name it angle C, is going to be your 45. Okay? Alright, well done. Keep up the good work, and just let me know if you've got questions.